So, hi children. Today we will be seeing numericals on chapter 8, part B. Okay. So, your first question is you observe this diagram. So, here you have an EMF, and this is the internal resistance of the cell, which is 1 ohms. You have an external resistance connected, which is of 4 ohms. You have a key and an ammeter with the voltmeter connected in parallel with the cell. Okay, so this is the circuit you have. You have to find out the voltmeter and the ammeter reading in two cases. First case is when the key is open, what will your ammeter and voltmeter show? And secondly, when the key is closed, what will your ammeter and the voltmeter show? Okay, so this is your question. So your first question is when the key is open. So when the key is open, you tell me now, will any current flow in the circuit? No. No current will flow in the circuit when the key is open. So your ammeter reading will be 0. Okay, but there is voltage across the cell. So your voltmeter will give some reading. So let us see what that reading is. So your voltmeter reading will be, your total EMF will be the terminal voltage plus the voltage drop across the cell. Okay, so it is denoted as capital V and voltage drop is denoted as small v. Okay, so this is what you need to find out. Capital V is what you need to find out. Okay, so EMF is given here 2 volts, substitute. Capital V is an unknown term, so retain it as it is, plus. This is the voltage drop. What is the formula for voltage drop in terms of current and resistance? Small v is equal to current into resistance, internal resistance. So internal resistance is denoted as small r. Okay, so now write V as it is plus what is the current? It is 0 when the key is open. Internal resistance is 1 ohm. Okay, so when you solve this equation for V, anything into 0 is 0. So your voltage is 2 volts. Now, second part of the question. When key is closed, you need to find out the current and the voltmeter reading. So the formula we will be using to find out current will be your EMF divided by your total resistance. Okay. So EMF is 2 volts. Your external resistance is 4 ohms and your internal resistance is 1 ohm. So substitute that in this equation. Now you will get this. When you solve for this, you will get 2 by 5 and 2 by 5 will give you 0.4 amps. This is your current value. Okay, now this is your current rating. So now we also need to find out the voltmeter rating, right? So your voltmeter will be EMF is equal to terminal voltage plus your internal, voltage drop. Okay, so you need to find out this capital V here. So when you rearrange this equation, when you bring capital V to the LHS, you will transpose all the other things to the RHS. When you transpose, you will get this form of equation. Okay, so now V is the unknown term, retain it as it is. EMF is 2 volts. Current is 0.4 amps, which we found out recently. Internal resistance is 1 ohm. So when you solve all this, you will get 1.6 volts. So that is the voltmeter reading when the key is closed. I hope you have understood this one. Okay, now let us move to the second question. So here you have a battery of EMF 3 volt. Okay, and it supplies a current to the circuit. Okay, so the current flowing across the circuit is 1.5 amps and your voltmeter reading is 2.7 volts. Okay, why is the voltmeter reading and the EMF different? Why? Because your EMF is the total voltage across the circuit, that is the terminal voltage plus the voltage drop which occurs, whereas your voltmeter will not detect the voltage drop across the circuit, right? Okay, so that is why you have a different value here. Okay, now we'll come to the question. You need to find out the internal resistance here. So your available data is EMF is given, current is given, voltmeter reading is given. You need to find out the internal resistance. This is your question. So let us use a formula. E is equal to, this is nothing but epsilon. Epsilon is equal to terminal voltage plus the voltage drop. So voltage drop, you can write it in terms of current and internal resistance. So we will write it. Small v is equal to current and internal resistance. So this we will substitute here. So your EMF is equal to terminal voltage plus current and internal resistance. Internal resistance is what you need to find out. So leaving this, rest all we will transpose to the other side. So this will become E minus V, and you'll be left with only I and R. When you transpose I also, it will come and divide here. Why? Because I is multiplying R. Okay, so it becomes E minus V by I, which is equal to the internal resistance. Now let us substitute all the values for the new derived equation. So what is EMF? 3 volts. What is voltage? 2.7 volts. What is the current? 1.5 amps. When you solve all this, you will get 0.2 ohms. So that will be the value of your internal resistance. Now let us see question number 3. So here you have a circuit. Okay, in this circuit you have an EMF of 1.8 volts and the internal resistance of the cell is 2 ohms. You have, okay, now this is connected in series with an external resistor R1, which will give you 4.5 ohms resistance, and this is connected in series with an ammeter, which will give you the current rating, and the resistance of ammeter is 0.7 ohms. Okay, so now this is the circuit you have. You need to find out what would be the reading of the ammeter. First, you need to find out the current reading. Second, what is the potential difference across the terminals of the cell? So across the terminals of the cell, what is the voltage reading? So these two are the things which you need to find out. So the given data is EMF is 1.8 volts, R1 is 4.5 ohms, R2 is 0.7 ohms, and you have internal resistance of 2 ohms. So this is the data. Before finding out the current flowing in the circuit, you need to find out the total resistance offered by the circuit. So for that, you need to add all the resistance because all are in series. So internal resistance plus resistance of the external resistance and the resistance of the ammeter. So 2 plus 4.5 plus 7.7 will give you 7.2. This is the total resistance. Now, what is current? Voltage by resistance. So what voltage we have here? We have the EMF value. So it is 1.8 by 7.2, which will give you 0.25 amps, and that is your current reading. This is the first part of the question. Your second part of the question, you need to find out potential difference across the cell. So across the cell, if you need to find out, you need to find out the resistance offered externally for this cell. What is the resistance externally offered for this cell? So here the resistance will be R1 plus R2, which is 4.5 plus 0.7, which is 5.2 ohms. So using this resistance, we need to find out the voltage. So what is voltage? Current into resistance according to Ohm's law. Okay, so substitute the values. V is equal to 0.25 amps current and 5.2 is the resistance. When you multiply these two, you will get 1.3 volts. So that is the answer. Okay, now your fourth question is, the music system draws a current of 400 milliamps. Okay, you have a music system playing and it consumes 400 milliamps when it is connected to a 12 volt battery. So here the question is, what is the resistance of the music system under this condition? Secondly, now you've left the music system to play for a long time. The voltage supply drops. Okay, when the voltage supply drops, what happens? The music system also stops playing. Okay, when the music system stops playing, your current is 320 milliamps. Now they are asking at what voltage drop does the music system stop playing? You need to find out. Okay, so first let us solve the first part of the question. This is the data given. Current is 400 milliamps. Milli means 400 into 10 to the power minus 3. Okay, you need to convert it into amps and keep it for solving this sum. Okay, so when you solve it, you will get 0.4 amps. Voltage across this music system is 12 volts. Resistance you need to find out. R is equal to V by I according to Ohm's law. Substitute the value. V is 12, current is 0.4. So 12 divided by 0.4 is 30 ohms. Second part of the question. Now current drops to 320 milliamps. And your resistance here is 30 ohms. 30 ohms is the resistance we have now. We have found out. So at what voltage will the music system stop playing is the question. So again, V is equal to IR. So I is 0.32. R is 30. When you multiply these two, you will get 9.6 volt. So at 9.6 volt, the music system will stop playing. When the voltage drops from 12 volts to 9.6 volt, the music system will stop playing. Okay, this is your fifth question, and it says a current of EMF, okay, E and internal resistance R sends a current of 1 amps when it is connected to the external resistance of 1.9 ohms. Initially current is 1 amps and external resistance is 1.9 ohms. Okay. Secondly, but it sends a current of zero point 0.5 amps when it is connected to an next you have a current of zero point 0.5 amps when the external resistance become 3.9 ohms. So here what you have to find out is you have to find out the EMF and the internal resistance. Okay, so now since we have two cases here, we will solve it individually. In the first case, current was 1 amps and resistance was 1.9 ohms. What is EMF? Current into resistor. What is the resistance? External resistance plus the internal resistance. Okay. Now EMF is current is 1 amp, substitute. External resistance is 1.9 ohms, substitute. Internal resistance you don't know, leave it as it is. Now you got an equation here, name it as equation 1. Second case, when you have a different current and a different resistance. Okay, same formula. E is equal to I into external resistance plus internal resistance. So now the current is 0.5 amps and external resistance is 3.9 ohms. Internal resistance you don't know, leave it as it is. So now when you solve, you got an other equation, that is equation 2. So when you observe both the equation, what you can find in common? LHS is equal. So since LHS are equal, you can equate the RHS. Okay. Now let us equate. 1.9 plus R is equal to 1.95 plus 0.5 R. Okay. So that is what I have written here. Okay, now let us group all the like terms together. We have an R term and an R term. We have a constant and a constant. All the R term will bring to LHS and all the constant will bring to RHS. Okay, so R is already there in LHS. This is plus 0.5 R. When you transpose to LHS from RHS, you will get minus 0.5 R. Now constants when we group, already 1.95 is there in the RHS. Now let us just transpose 1.9 to the RHS. Okay. Now 1R minus 0.5 R is 0.5 R. Similarly 1.95 minus 1.9 is 0.05. Now R is not separate, so you need to transpose 0.5 also. So R is equal to 0.05 divided by the 0.5, which will give you 0.1 ohms. Now we have found out the internal resistance. One part of the question we have found out. Still we need to find out what? EMF. For that, you can choose either equation 1 or equation 2. I have chosen equation 1 here. And I have substituted the value of internal resistance here. When I substitute and when I add these two, I will get EMF. So that is what we have done here. So here when you observe, I've taken equation 1, that is 1.9 plus R. So 1.9 plus, what is the internal resistance we've got? 0.1. So 1.9 plus 0.1 is 2 volts. So that is your EMF. So we are done with the fifth question. Now sixth question. Sixth question, when you observe, you have two resistors having resistance 4 ohms and 6 ohms. Now we have two resistors of 4 ohms and 6 ohms and they are connected in parallel. Find their equivalent resistance. So what is the formula we use? R1 R2 by R1 plus R2 for finding parallel resistance. R1 is 4 ohms, R2 is 6 ohms. When you substitute that in this formula, you will get 4 into 6 divided by 4 plus 6, which will give you 2.4 ohms. Okay, now let us see the seventh question. The seventh question is, 4 resistors each of resistance 2 ohms are connected in parallel. What is the effective resistance? What is the effective resistance? So you have 4 resistance each of 2 ohms. 4 resistors are there, each are 2 ohms. All the 4 are connected in parallel. So what is the formula we will be using for to find out the total resistance? 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4. Why? Because all the 4 resistors are in parallel. Now substitute the value. 1 by R1 is 2. All the resistors are of 2 ohms. So half plus half plus half plus half is 2. So your total resistance will be 1 by, see, 1 by RT is 2, which is nothing but 2 by 1. When I take an inverse of this, it will become RT. Similarly, you have to take an inverse of 2 also. When I take an inverse of 2, this will become half, and my total resistance will be 0.5 ohms. Okay. Now, your eighth question is, you have 3 resistors of values 2 ohms, 3 ohms and 5 ohms. How will you join them so that the total resistance is less than 1 ohms? See children, here 2, 3, 5. These are all bigger values. When you add them, you will get 5 plus 3 is 8, 8 plus 2 is 10 ohms. So if you take all these resistance in series, the resistance will increase up to 10 ohms. Okay, now they are asking you have to connect in such a way that you get the total resistance as 1 ohms, which means when you connect all three, the resistance has to decrease. So how you should connect? You have to connect all the three in parallel so that the resistance will decrease. Okay, draw a diagram to find the total resistance. So what will the resistance be? R1 in parallel with R2 in parallel with R3. This is how your diagram will be. This is 2 ohms, 3 ohms and 5 ohms. This is your diagram. Okay, when you solve this, it will be, so all three are in parallel, right? So it is 1 by R1 plus 1 by R2 plus 1 by R3. Substitute all the resistance value. When you solve it, you will get approximately 0.968, which you can approximate to 0.9 or you can approximate to 1 ohm. Okay, so now you have received 1 ohm. So this is your answer for 8th question. So your 9th question says you have 3 resistors each of 2 ohms, okay, and they are connected so that the total resistance becomes 3 ohms. Now imagine when you connect all the 2 ohms in parallel, then what will happen? Half plus half plus half will get 1.5. When you find out the total resistance, it will become inverse, right? That is 1 by 1.5 will give you 0.6. So when you connect all 3 in parallel, you will not get 3 ohms. So think how you can solve this. So how you have to connect it is 2 resistors you connect it in series, sorry, parallel, and 1 resistor you connect in series. Then you will get 3 ohms. Okay, now we have 2 ohms, 2 ohms connected in parallel. When you solve that, you will get 2 into 2 divided by 2 plus 2, which is 1 ohm. And one more resistor is connected in series of, this is of 2 ohms, right? So 2 ohms plus 1 ohm will give you 3 ohm. Okay, next your 10th question. 10th question, you can solve it yourself. It is very easy. You have this diagram, find out the total resistance. So you have 2 resistors in parallel, so find out the resistance of that. When you solve, you will get 1 ohms. Next you have 2 resistors in series, and this is in series again with this entire resistance, right? With RP it is series. So 2 plus 2 plus 1 ohm will give you 5 ohms. That is your 10th question.